Assalamualaikum, my name is Farhan Ikhwan bin Zolkipli. My ID number is 2019202034. Today, my team will present about the plastic container and the process that involved in this plastic.
So before I start my slide, our group contains 3 of members. There is Ahmad Aiman bin Ahmad Nizar, Azad Harith bin Ghazali, and lastly Farhan Ikhwan bin Zolkipli.
So there are many types of plastic container process. So the first type is injection molded. What is the meaning of injection molded? Injection molded is a manufacturing process widely used for plastic bottle production, which is also known as its high volume production capacities, low cost per part and good tolerance. All thermoplastic can be used in injection molded, with the most common material being such as polystyrene, polypropylene. During the manufacturing process, polymer granules are first melted and then injected into a mold cavity to form the final shape of the container, where the liquid plastic cools and solidifies. So the temperature in this process is in between 100 degrees Celsius until 300 degrees Celsius. So the raw material of this process is polyethylene, terephthalate, PET, polystyrene, PS, polypropylene, PP, polycarbonate, PC, polyethylene, PE. Okay, so we move to the next part is the process of injection molded. So the first process is the mold closes. The injection molding cycle timer begins when the mold closes. In some cases, as the use of robots, the cycle runs part to part, which means the cycle begins and ends when the robot receives a new part or new parts touch the conveyor belt. So the next process is injection mold. The heated plastic is injected into the mold. As the melts enter the mold, the displaced air escapes through vent in the injection pins and along the parting line. Runner gate and vent design are important to ensure the mold is properly filled. So the third process is cooling. So in this process, once the mold is filled, the part is allowed to cool for the exact amount of time needed to harden the material. So cooling time is dependent on the type of resin used and the thickness of the part. Each mold is designed with internal cooling or heating line where water is cycled through the mold to maintain a constant temperature. So the next process is plasticizing the resin. While the part cools, the barrel screw retract and draw new plastic resin into the barrel from the material hopper, and the heater bands maintain the needed barrel temperature for the type of resin being used. So the next process is ejection. So the mold opens and the ejector rod moves the ejector pin forwards. The parts fall and it's captured in a bin located below the mold. So we can see the process at the right of the picture. So the next process is removing the runner and packaging. Although the injection molding machine cycle ends on step 5, the process continues. Periodically, the machine operators or robots separate the usable parts from the leftover runner. The runner is pathway that the plastic takes to fill the mold cavity. In many cases, the runners are ground and recycled to reduce cost and environment impact.
Next, my team presentation will present the next parts. So that's all from me. Thank you.
Okay, so hi, assalamualaikum. My name is Ahmad Aiman bin Ahmad Nizar, and today I'm going to talk a little bit about blow molding. So first, let's talk about the definition. So blow molding is a method of making hollow, thin wall custom plastic parts. It can make product with a uniform wall thickness. For an example, bottles, plastic drums, and fuel tanks. blow molding costs less than an injection molding. So the temperature used for this process is between 10 degrees Celsius until 100 degrees Celsius. So there are 6 raw materials that can be used in this process. So first is polyethylene terephthalate, PET, polypropylene, PP, polyvinyl chloride, PVC, polystyrene, PS, polycarbonate, PC, and acrylonitrile butadiene styrene, ABS. And next, there is a video to show you a little bit about blow molding, and let's watch it. Okay, now I'm going to talk about the advantages and disadvantages of blow molding. So the first advantages of blow molding is it can produce a variety of products. So most plastic containers on the market today that hold some form of liquid has went through this process. In fact, the commonness of blow molding has allowed engineers to try and create a variety of application and design. So the second one is it comes with low cost. With a focus on extrusion blow molding, it uses a lower level of pressure, which means that machinery costs are low, making it easier and more cost efficient to mold external thread or open-ended and large part, which can be split by opening a closed molding. Moreover, the use of this technology will allow you to reduce labor costs. And the third one is allow multiple methods for production. As already implied, blow molding uses various methods to create final product. Now this technology is continuing to develop to improve such production method, using tweaks in design and moving toward pure automation. So the fourth one is it promotes a higher level of productivity. This technology has always been moving forward with the purpose of becoming universally used with plastic production. It has allowed for a significant increase in production capabilities, allowing manufacturers to produce greater quantities in just a short period amount of time. Using machines that allow for 3D molding, it has allowed for a production cycle that is much faster. And the last one is it offers the benefits of automation. Blow molding was taken to a greater height when the Placo XY machine from Japan was developed, giving rise to the 3D blow molding. So that's about it for the advantages of blow molding. And now let's talk about the disadvantages of the blow molding. So the first disadvantages of blow molding is it is highly dependent on petroleum. Like the gas industry, the blow molding sector highly relies on millions of gallons of petroleum to be able to produce plastic product. Second one is it creates a huge impact on the environment. As this technology depends greatly on petroleum and is an integral part in producing polymer, it carries a huge risk on the destruction of the environment. So the third one is it requires a lot of production methods. While it is an advantage that this technology uses multiple production methods, it also can be a disadvantage. As you can see, it will need more resource and the process could not be streamlined, thus removing correspondence in the process. The fourth one is it comes with limited use. Considering that blow molding is limited to hollow form such as bottle and plastic containers, and air pressure is essential to the process, it would come with limited use. For example, it will experience difficulties with wall thickness, which is difficult to control. So last one is it requires process and material precision that create waste. Although this technology already uses automation to produce high quantities of product, it is still limited to hollow form. It can result in wasted material from processing containers with specific dimension. That is all from me. Thank you for watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azad Harith bin Ghazali, and I will continue the presentation from the title of plastic containers, and I will explain about the defect that could happen during fabrication process. So, as you can see in the slide, there are three defects that could happen during fabrication. There is blister, burn marks, and burrs. So, for the first defect, blister, a blister is a raised region on the surface of a piece of plastic. It is usually caused by heat or cooling or venting, whether it is too much heat on the tool or insufficient cooling. Next is burn marks. The defect appears on the plastic as burn markings, black discoloration that mimic scorches. The causes for this defect is lack of resin ventilation. It is generally situated at the furthest away from the ventilation gate. And lastly, the last defect is burrs. When additional parts or scraps are connected to the completed components, burrs form on injected plastic goods. Burrs caused by dull or incorrectly diced or molds. By sharpen or clean the dies, this problem can be fixed. That's all from us, and I hope that this presentation is loud and clear. Thank you.